Okay, apparently I can't get enough today. I'm back doing AOC, Advent of Code. Someone asked me in my course about this first day one here. And so day one, if you recall, we have this little function here that says get nums that sum to. We pass in a sequence, and then we loop over both sequences in our solution to see something that sums to that. Now, the question was, can we make it run faster? So the runtime of this is O(n) squared. We're looping over a sequence that could have n things in it, and we're going to hit all n things in the worst case. So that this would be an O(n) squared. So can we make one that's faster? So yeah, we can make one that's faster. Let's just do that for fun. So we're going to get nums that sum to, and we're going to call this the fast one. So let's think about how we could make this faster. So n squared means that we're hitting all n items. For every item, we're hitting every other item. Do we have to do that? So think about it. We've got a list of numbers, and we want to see if a number sums to a number in that will sum to another number. So what we can do while we're looping over that is we can keep track of, instead of what we can do is keep track of the numbers we've seen. And then we know what number we're looking for. We're looking for, in this case, 2020 minus that number. We can check and see if that's already in there. So I posit that we can make this run in n time if we use a data structure like a set that does quick lookup and presumably isn't having hash collisions. So the way I'm going to do this is I'm going to loop over my sequence, and I'm going to, as I'm looping over it, I'm going to keep track of what I've seen, and then I'm going to check if 220, the number we're looking for, minus our current number, is in there. And if it is, I'll return. So the runtime of that should be order of n rather than n squared. So let's just do that here. Here's our old implementation. I'm just going to do our new. I'm going to say scene is equal to, and we have to say set as a set constructor. We can't do a set literal, and I'll say for val in seek, and then I want to say that scene.add val, and then what I'm going to do is check if the other number is in there. So if some result minus val in scene, then we're going to return val and some result minus val. Okay, and I believe that should work. So this here is we're only looping over it one time, right? We're looping over the values one time, and then we're adding them to a dictionary, and then we're looking, or not a dictionary, we're adding them to a set and looking if they're in the set. So set lookups, those are very quick because they use that hash mechanism. If we don't have hash collisions, those will be order of one. So the runtime of this will be that value there. And so let's, so I've got main here, and this is part 2. So we don't want part 2, we want part 1. Get nums that sum too fast. So I'm going to so here's that sum to, and here's that sum to fast. So those of you who are watching at home may notice, hopefully my Emacs is faster. I actually am using the Windows subsystem too. So we'll see if this actually does anything. I'm going to print res and res2, and let's run this. I got to change into this directory here. Okay, so Python 3 day 1, and I got invalid int for num tools here. Okay, so this is nums that sum to. What's going on here? Oh yeah, I need to, in this one I have a command line here. Okay, so there we go. I need to pass that in as the command line option. So this is the result I got, 1073 and 937. So I think that answers the question there. That is a fast implementation of that. Now this one down here, part 2, I'm not actually sure how to do a fast implementation of this. I guess what we could do is we could take that idea and instead of making n cubed, we could make it n squared. Oh, let me share my screen. Sorry about that. In fact, what I'll do is AJ, I'm just going to restart this. So I'll just redo this since you couldn't see the screen. Then I've only been going for 6 minutes. So I'm going to sign off and then I'll hop back on.